Welcome to HWE.DESIGN website. The website is built based on first principles. We initially going to talk about the theories we build out the building blocks for circuit design. Then we're going to look at different type of systems, such as digital system, power system, audio system. Then lastly, we're going to talk about how the product is made through different stages, such as concept stage to prototype, all the way to the manufacturing. And the process repeats. And this is known as system engineering. To understand the building blocks, we need to understand the theories governing these principles, these physical phenomena, such as stabilities, Maxwell equation, scaling effect, grounding, transmission line effects for high speed, etc. After we understand the theories, then we're going to move to the actual component that goes into these designs. Without going into too details, these are divided into multiple fundamentals. Right? The E basics will consist of filters, digital components, analog components, power electronics, basic signal transmission theory, and how we protect ourselves through IC protection circuit, such as transient voltage suppressor. Once I understand how these basic building blocks, they're going to move to more a modern system on digital computing systems. As we know, most of the products that we have in stores are essentially a variation of digital systems. And one of the key aspects of digital system is digital communication interface. Two types: high speed interface for high speed data transmission, such as interfacing with cameras, and low speed interface for low data output, such as interfacing with your accelerometers. Then we're going to move to typical computing systems, which usually consist of four things: the compute engine, the storage of your files, and the memory it needs to fetch these data and store it in a fast manner. And the peripheral device that's attached to the compute system allows you to send commands, retrieve data, and interact with the world. Once we understand the building block of basic computer system, we're going to embedded systems, meaning this computing device is embedded in a product that does one thing, a more specific version of a computer system that has one purpose. The most important thing will be microcontrollers or microprocessors that does perform some logic for this embedded system, what kind of operating system that is, how do you actually build it securely, and how do you allow real-time processing. Once we understand that, those four components are essentially what the embedded system is about. How do you design them? Since these products are miniaturized, we need to understand how are the batteries chosen, such as lithium-ion battery. How do we charge them? Right? What are different standards? Once we understand the digital part of things and how the battery and charging is like, we need to cover other subsystems of this digital system. The first thing will be audios. What is audio? How is audio wave transmitted and received? What are the audio transducers to transform the energy between electrical domain and the pressure wave domain? For the digital interface, compute engine needs to talk to get to stream data or extract data. Similarly, we need to understand how is RF communication work and what some common wireless standards such as Bluetooth and Wi-Fi. Then we need to move on to understanding antennas. What is its radiation principles? And what are things we need to watch out when we design these antennas into a small device in our embedded systems? As the product is coming to shape, how do we test them? How do we optimize them? And these are the following five things that we talk about, which is EMC, how the device is immune against noise, how its emission does not generate unwanted noise, which will fail some FFCC standards. How do you manufacture this device? How do you manufacture PCB? What are some important rules for you to check to make sure the PCB are well designed and can be mass produced to reduce cost and errors? And what are some checks we can do to check these designs and make sure they're good? And how are factories set up? Different test stations set up and manufacturing stages to assemble the product. So we're going to talk about, as well as this website also emphasizes, is hardware development. How do we actually go from concept phase to the actual product or realization of that concept? It's through first stage architecturing. It essentially is path planning. Once we figure out what the path we need to do, what are some components that were selected to meet that solution, then we realize that through schematic capture, which is the implementation stage, and then the PCB design, which is the physical design of that schematic capture. Once the product is being produced, we need to make sure it complies with safeties, different importing and exporting rules to different countries, so the product can be shipped and arrived without any issues. Once we understand these design fundamentals, a actual product, the focus for the EEs should be how do we build a system that's best at what it does. What does that mean? That means a system is composed of elements. In a larger digital system, elements are actually subsystems such as power system, sensor systems, wireless system, etc. In this section of the website, we are going to explore some common block diagrams of these systems and explain its theory of operations and the choice we made to select the components. Then we're going to deep dive how do we test these components through various test plans. Once these functional blocks are tested, how do these systems coexist with each other? Could there be any interference among each other? This is called system coexistence test. And one of the things we really care about is desensitization of the radio. Once all these tests being done, we also need to understand how our product endure against environmental factors such as high temperature, high humidity test, long-term operability test, mechanical reliability test such as vibration or drop test, scratch test, and lastly, some radiation FCC rules. Once we understand the system, how they're constructed, and their components work in synergy of each other, then we're going to take more in depth on how we actually build these digital systems. How do we actually build a power tree? How do we select the right clocks? How do we power budget our system so the target power does not exceed its source? Now, lastly, we're going to focus on product development process. Who are the teams and what do they do? How do you design a product from concept phase to prototype to mass production? How do you repeat that design process multiple times over generations of products? What are the different types of manufacturing? In-house versus outsourced versus joint design? And what are some typical manufacturing processes and quality controls? Lastly, we're going to talk about different type of other systems, such as robotics, imaging, etc. This concludes the overview of this website. I hope you find this useful and feel free to reach out.